Hi, my name is Sandra Coronado. I am one of the peer academic coaches at the STEM Center. I will be doing your college algebra refresher. About this refresher, I will be going over 5 of the most common challenging chapters in college algebra. I'm not necessarily expecting you to learn and understand and learn how to answer every single question. Of course, if you know and you understand it, that is amazing. That would be really beneficial for you. But I just wanted to give a brief introduction of what to expect, as well as what the information in these chapters looks like. I have also attached additional examples, videos, and resources that you can use throughout the semester. So if you ever want to go back into utilizing anything that I've put here, you're more than welcome to. Of course, if you have any questions or would like to work on any of these problems with me, you're more than welcome to set up an appointment as well with me. My email will be attached to the end of the presentation. So if you have any questions, please feel free to reach out. So, what are some of the topics we're going to kind of go into? We're going to be doing domain and range, interval notation, graphing lines, parabolas, quadratic equation, and synthetic division. These are all very complex chapters, but they can also be very fun. So before we get into the fun stuff, I really wanted to just go over some vocabulary. I know that the language in math can be sometimes a little intimidating and hard to understand, so I just wanted to share with you guys some of the common terms that you might hear your professors use through the semester. So perfect square, exponent, order of operations, variable, radical expression. You might hear as the semester goes by, but I just wanted to give you a little brief definition of what that means. I've also attached a Quizlet somewhere at the end of the presentation. So it has more vocabulary, in which it's kind of like you don't have to know every single little thing, but in case you want to be familiar with what things mean, you can utilize that. So that's a resource available for you as well. So, with that being said, what is domain and range? So, if you look here, I have 2 examples with the graphs that I got from this YouTube video. So, if you wanted to go back into going into more detail about it, you're more than welcome to look into it on your own. So, with this, I just wanted to show this graph right here. So, pay attention to your y-axis and your x-axis. With domain and range, we're mainly going to be paying attention to where domain lands, meaning what value is domain. So notice how domain goes across this graph. So across meaning the x-axis. So notice how, although it's not necessarily on this line right here, it still represents the x-axis. So domain has the x values. And then range, which is over here on the blue, you see that it goes down. So meaning that it's going down the y values. So range, y values, domain, x values. So some of these examples already give us kind of like points in graphs. So we have -6 and 6, -2, -1 and -1, and all of these wonderful points that we have. So let's just pay attention to the domain. Notice how this is -6, then we have -1, and then -1, and then 1, and then -6. These are all the x values. So we're going to note them for the domain right here. So notice how this is -1, -6, -1, and 1. Notice how although there is technically 2 -6, this one, and then this one over here, we only wrote it down here once. You don't have to write -6, -6, -1, -1, and then 1. You can only just write it once in the number line, and it'll be correct. Same thing with the range. You just have to write it once in the number line if the number repeats. But now, instead of domain, notice how domain is the what? The x values. Since these are the x values, now we do the same process, but now we do it with the y values. So that's why you have -2, -1, -6, and just 6. Same thing repeats here. And then go ahead and look into that video for more examples. Okay, so here I did a check your understanding. So once you click onto this link, you should have it looks like a little, it kind of looks like Kahoot. You have it available till January 16. If you need a code, the code is right here. It has just different questions in which you can practice your understanding. If you have any questions regarding that, or if you would like to work it with me, you're more than welcome to. We can set up an appointment and so. All right, interval notation. I know that this is a very big description of what it might mean, and it might seem a little intimidating, but let's just look into this graph right here, and let's just pay attention to the greater, the less than, and then the equal to down in the bottoms. All of these will be the indicators of what to pay attention to here and what this means and translates onto this number line over here. So one of the biggest things with interval notation is understanding what everything means, because there's so many varieties. Notice how this has two close dots, this has two open ones, this has a close one, this one has an open one, then they switch. Well, what does that mean? That means that right here your inequality has a different description. So all you have to do is just pay attention to that greater or less than or equal to in between your values of either whatever variable a and then x and then b. Whatever way there's a number or value is there, just pay attention to where the arrow is going, or if there's anything below it. That little equal to sign will indicate you if it's an open circle or a closed circle. So going back to this example, notice how on both of here we have a closed circle because, the closed circle is right here. We have this closed circle because we have the equal to sign right in the bottom. So we represent it in the number line like this. Well, how does it look like when we don't have one? Well, if you notice right here, you don't have one, so both of them are open. But notice how we go down here, this one is open, this one's open, this one's open, this one's closed, this one's closed. Well, the only difference is that this one has an equal to, and then this one doesn't. This one doesn't, this one does. So meaning the one that does have the line remains closed, the one without it stays open. So you see the trend going down the line. Pretty much you also have to pay attention to what that inequality is describing. So notice how we have here, this is just a and b, so we don't really know what values go in there. But notice how it starts looking a little different when you have infinity and a closed interval notation. So with infinity, it means that it's going to infinity and beyond, so there's no stopping. So the only number that you're going to have, or the only point that you're going to have in the number line, is if you have a variable right here. So for example, we have negative infinity to b. So notice how it's a bracket because this is an actual value, and we have that little equal to line in the bottom with the b value. So bracket. And then when we write the number line, since this isn't going to negative infinity, technically we could write a line to indicate that it's going towards towards negative infinity. But for the b value, notice how we have that little line again. So whatever b value it is, we would put it in the number line, and then we knew that it would be a closed circle, so you put a circle there. And vice versa, it works the other way around as well. So if you're going towards positive infinity, you would kind of do a little line going this way and just kind of like show that that's positive infinity. And then if you have a set value for a, then you would put it down in the number line. And since there's an equal sign, the little line on the bottom, you just go ahead and make sure that it's a closed circle. And same thing repeats with all of the above. If it does have one, if it doesn't, closed circle, open circle. What happens when you have two infinities? Well, since it's just going both to negative and positive infinity, you don't really have a point to indicate it. So you don't really have to write much. There's no closed or open circle, so you can just indicate that both of them are going towards negative and positive infinity. Once again, you can check your understanding on this particular chapter, which is interval notation. So this one's specifically for interval notation. So if you want to work on it, you have this little quiz game that you can do. Okay, so going to graphing and lines and parabolas. So this is a little bit more fun. I know that when you see this, you're not necessarily like, wow, I can really understand what's going on. But if you just pay attention here to the example, we are given an equation. What we're trying to basically do with the equation is just understand where it's going in its graph, like the coordinates. So we kind of make it equal to 0. So if you notice how this went to here, you just equal it to 0. And then from there, we're just going to try to find what the y-intercepts are. And then you're going to try to find the turning point. Then once you do all of the math, you substitute 0 onto where the x's are. Then you find that the value of y is 7. Then you're going to go find the x coordinates. So this is one of the equations you use, negative b over 2a. So what you do now is that you go into your original equation right here and you look for what the b value is in your original equation. So I know I didn't write it down here, but this is your a value, so the 4. Then this is your b value, the 10, and then this is your c value, the 7. So since this requires the negative b value, meaning that whatever number you have here, you put it in front here. So since this is negative 10 and this is calling for a negative b, two negatives make a positive. So this becomes a 10, positive 10, because once again, this is a negative 10 and then this is a negative b. Two negatives make a positive. So there's where the 10 goes. So now we do the same thing for the bottom. We have 2a, meaning that we go looking for the value of a, which is 4. Notice how it's positive. So what is 4 times 2? 8. So now you have 10 over 8. We can simplify that, so that can be simplified to 5 over 4. Then you're still going to do the y coordinates. So you over here we're going to put y equals, the original equation, y equals 4 times, and then wherever you see the x at, you're going to put what we solved. We solved for x. You're going to put that value into where you see the original x at. So you put this there, and then this there, and then you solve it all together. So here you got 3 over 4 overall. Now you're just going to go, and once you have all this information, you're going to go ahead and plot it. So this is your original equation, this is your y-axis, this is your x-axis. You can just translate this into decimal form, which later we have here, the y-intercept is 0 and 7. And then since this is here, it's a parabola, so it meaning that it's going to be the same on the other side. Notice how we have this little line right here. So now that's what we had solved over here, and that is our 1.25 and our 0.7 that we had discovered over here in both of these coordinates. So that's how you would graph a parabola. So if you want to practice that as well, you can go ahead and click on this. I'll give you another practice problems. Solving quadratic equations. So with quadratic equations, we have a formula, which is up here. One of the things that I also had mentioned previously is the A and B value and A, B, C value. So notice how this is like your A value, this is your B value, this is your C value. So this is what your quadratic equation looks like. So you're going to go in and you're going to actually put in the values that would represent the A and this A, B, and C into the equation. So for example, this is your B value, this is your A, and this is your C as well. This is your A. So you put in those values, you follow this formula, so you start working internally. So this times this, and then times that. You have that number, which is 16. Then you do the 3 to the square root, which is 9. So since you have that, you can add that. And then you're going to have this number, and then you have positive and negative, so you have two possible answers. You're going to follow the steps in how to just basically have -3 plus 5 over 4 and then -3 minus 5 over 4. That's what the positive and negative indicates. Simplify that, you get 2 over 4, -8 over 4. Then you can basically just check your work and see if it really, if these numbers fit into the equation, by meaning that if they give you the value of 0, which is what is here equaling to, and if they do, then that means that that is the x value, which is -2, and that's how you check your work. And of course, if you want any extra activities, you can use this one that is specifically for that chapter. Now, the fun one, synthetic division. You might be looking at this and you're like, well, what is happening? Well, let me explain it. We have, this is our problem. Let's follow y equals x 2 plus 5x plus 6. So notice how we have x, in front of x there's no number, but technically there's always an invisible one right here. Then we have 5x, so 5 is our number that we're going to focus on. Then we have 6. Notice how I said 1, 5, and 6. So let's bring those numbers down. Then after that, you're basically just going to test your zeros. So notice how we have 1, we put the 1 over here. Then after that, we're going to multiply those two numbers. So 1 times 1 is 1. So you bring it down here. I would suggest following the shape of this. That way it can help you divide the numbers that you're putting down and understand the flow of things. With that being said, we multiply these two. We said that it was 1, right? 1 times 1 is 1. So we jot it down. We put 1 here. Then we move on to the next one. We say 1 times 1. Okay, this one times this one. Then we multiply these two. So 1 times 1 is once again 1. So now that answer of this multiplication, we put it right here under the 5. So then you're going to follow the same steps. Well, sort of. You're going to do, instead of multiplying, you're going to actually be adding here. So add down the column. That's what you're going to be doing. So that 1 that you got here, you are still now going to add it to this 5. So 5 plus 1, 6. That's where that 6 came from. So let's just retrack again our steps. We have 1 times 1, which equals 1. So we put it down here. Then over here, this 1, we multiply with this 1. So if this were to have been a 2, then you would have multiplied 2 times 1. And then you would have put in a 2 right here. And then you would have done 5 plus 2. But since this is a 1 and a 1, you're just going to put 1. And then 5 plus 1 gives you 6. All right, ready for the next step? So since we have 6 right here, now we're going to go back to this 1, this one that we have over here, and we're going to multiply it. Of course, 1 times 6 is 6. So we put it right here underneath this other 6 that had been empty. Of course, since we did the adding on this one over here, we're also going to be adding this 6 with this 6. So 6 plus 6 equals 12. So that is pretty much on how you can actually carry on the synthetic division. So if you have any questions, follow these steps and you can for sure nail down how to keep track of every single number, what gets multiplied, what gets bring down, what gets moved over here, what gets added. Once you do it over a couple times, you get the hang of how things work. And of course, another activity in which you can do. I listed some YouTube video here. It's a little long, like 3 hours long. I wouldn't suggest watching the full 3-hour long video, but it covers a lot of different chapters and topics of college algebra. So if you just wanted to I don't know what this is, or I don't understand this, I would suggest maybe look at that chapter or maybe look at the video for 10-15 minutes, and it can be really helpful. But don't spend your whole time trying to understand it, the whole 3 or 2 hours that it's long. As well as I put it here, some additional content that can help is Khan Academy. This is their direct link to all of their college algebra stuff. So if you're looking for a specific chapter, just go down the list and click on it and it'll send you to the videos, once again, activities, any other resources that you need. I would strongly suggest using this one. And then another YouTube channel that I would suggest using in case you have any questions or you need just help outside tutoring hours is this YouTuber called the Organic Chemistry Tutor. I know that that sounds like, oh, this person's teaching or tutoring in organic chemistry. They do, but they also tutor in different in other subjects, and one of the subjects that they have videos on is actually college algebra. And myself included used those videos when I was in college algebra, so I could strongly recommend those resources. These are all resources that are available to you 24/7. So I would say take advantage of it. When you, let's say it's a Saturday and you have a question on how to work a problem out, this is a great resource. Of course, these are my recommendations. So if you have any questions, just let me know. And then, I mean, you can come, right now I know we're remote, but since if we do go back into person, you can find me in the STEM Center, which is in Brussels Hall, room 100. And if you have any additional questions, just go ahead and send me an email. My email is down here below. It's sandracoronado42@alamo.edu. So thank you so much for joining my refresher course. I wish you the best of luck in college algebra. You got this, and make sure to come by the STEM Center anytime you need us. Have a good day.